Hello, this is going to be a discussion about the AGR thickness pen and its use in capacitive mode to measure thickness of various materials. So first thing I'll do is I'll turn on the thickness pen and it'll go through its AGR logo boot sequence. This is an important discussion because with capacitance mode there's a variation in measurement based on the material. So first let's enter capacitive mode with the square button, and it'll show a square on the display and an hourglass as it initializes, taking a reading with no object around it, a clear air reading. When that's completed, you could see that when you put your hand or anything near it, it measures it. So what you can start by doing is checking if it's in the calibration for the material you need. So let's start with glass. So a glass target comes, and it's a soda lime glass, and this target is 0.1287 thick. So I could put it in the holder and see if it reads 0.1287, and it's within spec. So if I measure glass and I get the right reading, I change to PET, which is a rigid thermoform plastic, and this particular object is 0.1087. If I put it on, I'm getting 0.032, very low. So that's a sign that it's calibrated for a different material. And the same thing would hold true if I put on HDPE, which is another thermoplastic. This should be 0.1234. It's measuring 0.017. So it's not accurate for any material other than glass. So again, this was 0.1287 in glass. And it's measuring 0.128 or 127. So that makes sense. So how do you calibrate to another material? Let's go ahead and calibrate to the PET sample. So this sample is 0.1087. So I enter calibration mode by holding the oval. It beeps and gives a reading to type in, and I do 0.10 by lowering the number with the square button. 10. I go up a little bit to 8.7. I hit the button again and it tells me to let a zero reading occur, which means leave the tip free of any object. It'll take about 10 seconds. Now it's asking for the object of the thickness you put. So I'll put that object in, it beeps, and you let it read the object for 10 seconds. Okay, now you can remove the object, and now it should be calibrated for this PET sample. Okay, it is 109. So if I put the HDPE sample, which is a different thermoplastic, it should read 1234, but it will not. It's reading 0.041. So PET and HDPE are very different in the dielectric constant, and you can look it up. They are different. So the next step would be let's calibrate for HDPE. So I go ahead and hold the oval button, and I need to put in the number of 0.1234 for this object. So I go up with the zero button, go down with the square button, accept it with the oval button, and wait for the zero reading to complete. Again, it takes about 10 seconds. Okay, now it's asking for the sample that you said is 0.1234 thick. Add that sample to the holder. Take your fingers away as soon as you can. It'll take a reading for that material based on the thickness you entered. It long beeps and tells you it's complete. Okay, so this sample should check out to be okay at 0.1234. and it's within spec. It's calibrated for HDPE. You can go and measure any HDPE sample. What about LDPE? You can see this is a little translucent. You could see through it a little bit. So LDPE is another thermoplastic with a slightly different dielectric constant. This should read 0.1229 or 123. It's not reading 0.123. It's reading thin at 0.100. So that shows that even HDPE and LDPE, which sometimes you could tell by the color, the dielectric constant is significantly different and they have to be calibrated individually. And when you make a sample for calibration, you can put it in your handy holder for future use to quickly go between materials.